Hi everybody, this is Professor Wells and we're going to review Chapter 13, Abrasion, Finishing, and Polishing. The process of finishing and polishing involves using a series of abrasives on a surface to first contour, then smooth, and finally bring a luster to the surface. Contouring is the act of cutting or grinding away excessive materials to produce the desired anatomic form. Polishing is the process of abrading the surface of a restoration with a series of coarse to fine particles to produce a smooth surface and an aesthetically pleasing surface. Cleansing does not produce scratches or wear and is primarily used for the removal of biofilm. The size, irregularity, and hardness of the abrasive particle determine the depth of the scratches in the material being abraded and therefore the amount of material being removed. If the surface being abraded is harder than the abrasive, little or no effect is noted. The size and shape of the particles are important considerations in manipulating the abrasive. Particles that are large and irregular will cut more efficiently. The sharpness or efficiency of the particle is usually lost with use as the edges break down and the particle no longer grabs the surface. Unlike the shape of the particle, the size of the particle does not always break down with use. Abrasive particles are classified from coarse to fine. The more concentrated the particles that contact the surface, the more quickly the surface will be abraded. If a lubricant is used to dilute the concentration of the particles, the abrasiveness of the material is reduced. Water and saliva are common lubricants used to dilute the effects of abrasion. Increasing the speed and pressure of an abrasive will increase the rate of abrasion, but will make it more difficult to control the handpiece and will build up heat on the tooth. Bonded abrasives are attached to a rotary instrument and have an abrasive particle uniformly incorporated in a binder to form the shape of the device. Coated abrasives are supplied on rotary discs and handheld finishing strips. Paste abrasives are found in the form of prophy paste and toothpaste. Loose abrasives are manufactured in powders and paste and are classified by their grit and particle size. These may be applied with wheels, brushes, cups, or soft pads. This figure shows various delivery designs for abrasives. There's paste, bonded, and coated. Many types of natural and synthetic materials are available for the use in dentistry. So these are just a couple to name off. Actually, there's quite a bit here. Pumice is one that we use pretty frequently during hygiene appointments. Let's see here. A diamond is used usually on the dentist side. They use that to file down fillings that have overhangs or to adjust fillings too. Prophy paste may be a mixture of pumice, tin oxide, and lubricants. It contains a mixture of 50 to 60% abrasive materials. Prophy paste may be 20 times more abrasive to dentin and 10 times more abrasive to enamel than commercially prepared dentifrices. When a prophy paste is selected, the least abrasive paste possible should be used for existing stains and soft deposits. These abrasives should be applied as wet as possible with a light touch at a low speed. This figure shows the grit and prophy paste. It's available as single dose units in holders, and it comes in various sizes. Over-the-counter toothpaste contains 20 to 40% abrasive agents, coloring agents, flavoring agents, and therapeutic agents. The abrasive agents improve the efficiency of the toothbrush in the removal of stains, food debris, and biofilm. The lowest possible abrasive rankings are desirable to prevent removal of softer tooth surface structures and restorations. This figure shows toothbrush abrasion. Notice that the effects of the abrasion are also seen on the amalgam restorations as well. Denture cleansers use mild cleansing agents to remove plaque and stain from the surface of dentures. Commercial denture cleansers should be non-toxic, non-abrasive, and harmless to the components of the prosthesis. The finished and polished restoration should have a smooth, continuous line flush with the tooth surface. When restorative margins end at or near the cemento-enamel junction, instrumentation near or on this cavo-surface margin may result in ditching or gouging of the softer cementum surface. Contours of teeth must be recreated and should not be flattened or overly rounded. Before finishing or air polishing an amalgam or composite restoration, the clinician should check the integrity of the cavo surface margins for extra material known as flash. The process of removing excess restorative material to bring the restoration flush with the cavo surface 2 structure is called margination. Careful evaluation of the restoration is necessary to determine whether margination is indicated. Amalgam restorations should not be polished sooner than 24 hours after they are placed, as the material needs to set completely. Rotary cutting diamonds and carbide burrs are used to reduce excess material at the cavo surface margin. Care must be taken whenever rotary instruments are used for the generation of excessive heat and aerosols. This figure shows a polished amalgam restoration, letter A, which is letter A, and an unpolished amalgam restoration, which is letter B. So you can see the difference in letter A is more shiny and has that nice luster, and letter B looks a little more rough. You can also look at the procedure 13-1 on pages 1216 to 1217 in the textbook. Composite restorations are finished and polished in 3 steps as part of this restorative procedure. Excuse me. Marginal and occlusal excesses are removed in initial finishing with diamonds and multi-fluted carbide burrs. Immediate finishing is accomplished with flexible discs, cups, and strips, beginning with coarse and proceeding to superfine. The final polishing is accomplished with the submicron aluminum oxide-based polishing paste applied with soft cups or felt pads. You can also look on page 218 and 219 in the textbook at the procedure 13-2 to get a little more info on that. Precious and non-precious crowns, inlays, and onlays are finished and polished in the dental lab before delivery to the dental office for final fitting and cementation. Rubber polishing points and wheels designed for porcelain are used for finishing, and diamond polishing paste is used to polish the restoration to an enamel-like luster. All restorative materials must be identified before the coronal polish to prevent undesired removal or scratching of the surface of the restoration by traditionally commercially prepared prophy paste. The clinician must consider it a 2 structure as well as restorative surface when choosing the most appropriate polishing or cleansing agent. Stains accumulating at the resin or cement interface must be carefully evaluated for actual staining or microleakage. If it's determined that the stain is within the cement and is not the result of leakage, it may be removed in the same manner as in composite restorations. Biofilm may be removed with special plastic hand instruments, plastic sheaths, or ultrasonic scalers, and non-abrasive paste or tin oxide. Air polishing is also appropriate for removal of soft deposits on implants. So it's really important that we make sure we're using the proper instrument on implants, because the implant itself, you don't want to scratch it. And the implant crown, you don't want to scratch that either, because that gives that biofilm a place to cling on to. The use of air to propel very small microparticles as a replacement for rotary cutting instruments has not proven to be as successful as originally expected and is seldom used in modern practices. Air polishing is very successful and widely used to remove extrinsic stains. Air polishing also utilizes a combination of sodium bicarbonate, air, and water at a pressure of approximately 40 to 60 pounds per square inch as a fast, effective, and efficient means of removing stains and soft deposits from the enamel surface. This figure shows an air polishing unit. Microabrasion uses greater compressed air pressure at 27 or 25 aluminum oxide powder particle size with a Mohs hardness ranking of 9. Aerosols are created whenever a rotary device and moisture are used. These aerosols can provide a means for disease transmission if the operator does not use proper PPE. Silica particles from restorations and mercury vapors pose potential health risks as well. It is essential that dental personnel are knowledgeable about what materials should be used with specific restorative materials. Using the wrong materials may cause irreplaceable damage to restorations requiring replacement. If you have any questions over the material covered in this chapter, feel free to reach out to me. My email is hwells14@ivtech.edu.